Welcome to video lecture on Intelligent Systems and Control. I'm Dr. A. Asanta, Assistant Professor in the Department of Electronics and Instrumentation Engineering, SRM Institute of Science and Technology, Katangalatore. So these are the topics I'm going to cover in this module. So this has 5 modules. In the first module, we're going to see the introduction of both the neural network systems. What are the different architectures involved in neural network systems? And the second module has the fuzzy system. Introduction, what is the a review of conventions, how we are going to switch over to the fuzzy sets and its introduction. What are the different terms we are using in this fuzzy system? And in module 3, introduction to neural control. What are the different algorithms or different methods that is used for a neural control, and how neural control is applied to robot manipulator. And the fourth module covers the unit of covers the topics, includes the neural control system, how the neural network plays a major role in control system. So we are going to see some different algorithms or different methods that is used for control, used in the control systems. And in last module, in the fifth module, we have fuzzy control system, how the neural network control, the same way how the fuzzy is applied to the fuzzy algorithms are applied to the control systems. So the entire 5 modules covers this video lecture series on intelligent systems and control. So before we are going to this topic, intelligent system control, we should know what is an intelligent system. So nowadays we have previously we use Google for searching any data. If I type anything in the Google, you will get some irrelevant information. You will get a lot of information you will get. In that, we have to select the whichever is applicable, that you will select, and we will research, or we will get the details, or we'll get the informations from the Google. But now we have ChatGPT. So in the ChatGPT, if I give only a sensors, it will give a lot of informations. Sensor, what is applications where we can use, or the different types of sensors, all the details, whatever we want. Instead of searching into different tabs, it will give the details what we want actually. So that is that we can get immediately within a second. So we will get all the full details about whatever we are expecting. So that is called as the intelligent systems. So now, have you ever interacted with Siri, Alexa, or Google Assistant? Yes, everybody have interacted. Some people have interacted with Siri on mobile phones, in Apple mobile phones. Some may be using Alexa, and some may be using Google Assistant. What it does? So whatever the details you are giving, it will give the details immediately. How that happens? Because they use the natural language programming to convert. Maybe Alexa and other things, whatever we are speaking, what it gets the spoken words and convert them into words, and then it processes it. So that makes us to understand. Sometimes it will, what if I say, give an explanation about the classification of sensors, it will hear the spoken words and convert into data, and then process, and it will give the details, so that we can make it, it will be in audible voice, or it may be in a texted mode. So that is what this Alexa, Siri, and Google Assistant will do. So whatever the information or the request given by the user, it will understand. For example, if I ask what is the weather today, what it will do, so immediately it will process the request. Our request is to check what is the weather today, and it will give the most appropriate response. So it will just see the words. So for that we are using different algorithms. The algorithms will help us or to learn the network, and after getting so many trial, and after getting learning, it will give proper responses. That is what happened in all Siri, Alexa, and Google Assistant. So they apply algorithms and knowledge base to the answer whatever the queries they're asking, or if there are any songs or any, if you want to control any smart devices. So all these things happened by applying some algorithms, and based on the algorithm, it applies some knowledge based things to respond to the queries given by the user. So I can say now an intelligent system, it mimics the human thinking. Whatever we think, the same only it will think, and helps in the task like if you're driving a car, or if you want to diagnose a disease, or if you want to play a chess. So intelligent systems, I can say that it is a computer-based systems. It is capable of making decisions. And second one is it is used for solving the problems. And third one is it's learning and adapting from the data. So we can have one activity like I can call one student, one person, and a person will be standing in front of the podium, and the user will keep on asking the questions. I can ask what's the name. Some people may ask what is sensor. Some people may ask what is intelligent systems. Some people may ask what is the Vijay latest movie. Some people may ask what is the gold rate now. Like that, various questions can be given by the user. So what that person will do, whatever he knows the answer, he will respond. If I ask what is the gold rate now, sometimes he do not know, so he'll simply pass. Sorry, I'm not able to answer to your question. And if we ask some other, which may be relevant or irrelevant, whatever the questions, if we ask, sometimes that person may answer, and sometimes he doesn't answer. What is the reason? So the same thing we are asking to the chatbot, but the chatbot is giving the response immediately within a second. But if you ask the same thing to a person, because only for certain things he or she can answer, but others he cannot able to answer. The reason is we can understand from this activity how what we are asking the questions. So this chatbot, I can say this is a chatbot. The person who's standing and answering is a chatbot. It depends on programming and training data to provide responses. So it has to be based on training, and based on the training only, the chatbot can provide some responses. The person who is standing there, if you're asking some questions, first time he is not able to answer. So it undergoes too many trainings. So when he knows the answer for those things, then if some person, if they ask the same question, he can able to answer because it has trained. Okay. So once it's getting how much amount of it is getting more deeply into the training, more accurate responses you will get from the intelligent, from the chatbot. So that we call it as intelligent systems. And now the person, he is very struggle to to give the answer for the unknown questions or complex questions or ambiguous questions. It's very difficult because he doesn't have lack of training. So what we have to do for such chat boxes, we have to improve their effectiveness by giving more learning as well as giving more training. So as the person learns more and more, he could answer for any questions. Okay, so if the chatbot has responding to your question, means it has learned many things. After learning so many things and after it's undergone various training, it can able to respond immediately whatever the users request. So this is called as intelligent systems. So I can conclude that the intelligent systems like a chatbot, it mimic human behavior, but they're limited by their programming. Yes, the person has only a limited knowledge. If the person trained and learned more, he has more of knowledge. So whatever the questions or whatever the request given by the user, the chatbot can easily communicate or easily respond. So as we learn more about the intelligent systems in this course, we will discover the advanced methods like machine learning and neural network that help to overcome these limitations. and create smart, more adaptive systems. So in this module, we are going to see what are the different advanced methods in machine learning and neural networks to overcome these limitations. What is the limitation? Because the person doesn't have, it has only the limited knowledge. How to make as an unlimited knowledge through these algorithms. So next comes the drawback of traditional algorithm. So traditional algorithm it does not perform with images, audio, video or text without significant reprocessing. So if you give an image, it undergoes traditional algorithms. It doesn't have not perform with images, audio, video and text, even though if it has some pre-processing techniques. And the traditional algorithm is always rely on manual feature extraction and selection, not the automatically. It will, by using the algorithm, it will not select the features and feature extraction and selecting the features. And third drawback is it requires a domain expertise. Domain expertise is required to identify the important features. Okay, that because some persons may have identified the features wrongly if it is a manual feature extraction. So we need a, that is what happened in the traditional algorithm. So algorithms like k-nearest decision, these are all sensitive and it has noisy data. So these, because of noisy data, it gives a poor performance. So if you want an accurate and good performance, then you have to train more, learn more, and apply new and advanced algorithms. And traditional methods are useful for simple systems and for the smaller systems, and it is limited to less suitable and handy for the for complexities and other modern data. It is not suitable. It will give only a poor performance. So now we are moving to the intelligent systems. So here comes the neural networks. Why do you want a neural network? So it is a powerful tool in machine learning as well as the artificial intelligence. How it works is how the human brain processes the information. So for example, if I'm boiling a water in the stove, so the moment when I touch the vessel, immediately I will take the hand because it I feel that it's very hot. So what happens here? You are getting the control signal from the brain. It insisting that it's very hot. So immediately we are taking the hands out. So this is what is the, this we call as biological neural network. The same thing we are going to apply in the neural network. So these neural networks are it gives it is very widely used because it has the unique ability to learn the patterns. It will understand the pattern, and based on the pattern it will make predictions. It will predict and then solve the complex problems when compared to the traditional algorithms. Traditional algorithms always struggle with recognizing the images, then understand the speech and predicting the outcomes. These can be overcome with the help of this neural network by making predictions, by learning the patterns, and for to solve all complex problems. So next comes the biological neural network. So this is the biological neural, because just we are going to see the mimic of this biological neural network. So first one is the dendrites. These are the dendrites. So dendrites is nothing but it receives the signals from the other neurons. Whatever the neurons you have, it will get the information from the other neurons. And you have the cell body. The cell body, it will, these are all the dendrites. So this is one signal, this is one signal, this is one signal. So each signals will be summed up to the incoming signals. That is what is the cell body. And after summed up, if the total signal reaches certain voltages, that means it will cross the threshold. For example, it will just when you touch the hot water, immediately we will take the hand. So that is the threshold for that person. The same person, if some other person touches that hot, they will casually they will take and take the vessel because their threshold is more when compared to this person. So that depends on the person based on their threshold values. So if it crosses the threshold, then only you are getting some signals. If it crosses the threshold, it will give some potential is applied. So due to the potential, immediately we are responding and taking our hands. So that we call as the motor neuron. So motor neuron always telling your muscles to pull the hand out. It will give some senses to take our hands. So some people they don't have senses, right? So they will keep on touch also. They will not feel anything. That means in that cases the motor neuron is not responding properly. Because of that reason, the person is not able to take their hands out. So once the threshold is crossed, the neuron rapidly depolarizes and sends an electrical signal to the axon. So once this axon, based on the signal from the axon, the person will respond. So the same thing we are going to mimic in the biological or the neural network. So it is a machine learning model to mimic the way how the human brain works. How the human brain is the same way it is going to mimic. So it learns the pattern from the data, then make decisions and solve the problems. So I can say that it is a decision making system. It is made up of number of neurons. So here, as in the comparison with the biological neural network, there you have different neurons. So here also we have all the inputs are considered as neurons, and all the neurons it undergoes process, and it produces some output. So the network learns by adjusting itself based on the training. It will adjust itself, and it will give the output. So this is the comparison between the components of biological neural network and the artificial neural network. Here you have the neuron, here you have the input layer. So it is like a basic unit, here also it's like a basic unit. Then dendrites, it receives the signals, and axon sends the signal, and synapse, it's just a junction where the signal is transmitted from to the next neuron, and signal, it may be electrical or chemical message. Here you have input layer, that is dendrites. Dendrites is to receive the signals. Here also it will receive the signals. And hidden layers, you have the hidden layer, it acts like a brain. So that will process the processing center. And then we have one more layer called output layer. It gives the results. And you have another term called weights and biases. So like synapse, it will transmit the signal, right? Similarly, here it will adjust the signal based on the type. It adjusts the signals and gives the output. So that will be given to the activation function. So it will decide whether the neuron should be activated or not. Okay. The same whatever we have seen. One is the input neural layer, and second was the hidden layer. Input layer accepts all the inputs and to be processed. And hidden layer, it is the intermediate layer between the input and the output, and it performs the immediate computations through the weighted connections and the activations. And next you have the output layers and weights and the biases. So weights and biases are adjusted for if you want to have more of learning during the training period, then you have to adjust the weights and the bias. So bias is nothing but it is an additional parameter that will be added to the weighted sum before applying to the activation functions. So this will allow the model to be more fit, more accuracy. So activation functions, it is a mathematical function that is applied to the output of the neuron in the neural network. And this produces some non-linearity. So that makes the network to learn complex patterns like ReLU, sigma and tan H. And next one is the loss function is nothing but the error. It is nothing but the difference between the predicted output and the actual. So we actual output, for example, I'm having an image. That image, that image shows that it is the person is having a cancer. So that is the actual output. But whatever the testing, when we are giving an image and testing, and it will predict some output. If it predicts the same as of cancer, then the loss is it is achieved. So the error is zero. There is no loss function. But if it predicts us as it is non-cancerous, then that much of error we have. How much accurately it has predicted with the actual output. That comparison we have to check. So based on the comparison, again we have to adjust the weights and learn the network to until you get the accurate response. Some algorithm, if you are having uh, testing also, it will get the same out. It will not improve it because the learning rate is less. If you have more number of learning, then it will predict the output accurately. The next one is optimizer. It will allow you to update the weights and the biases to reduce this loss function of the error. And the next one is the learning rule. So learning rule is the methods that is used to adjust the weights and the biases. So by adjusting the weights and biases, we can improve the accuracy, time as well as the accuracy. So these are some of the types of activation functions. One is the sigmoid function. So it is a mathematical function. That is 1 by 1 plus e power minus x. So the output value is between 0 and 1, and it is used for the binary classifications. And ReLU is the rectified linear unit. It is a maximum of 0, x. X is the inputs, and tan h equal to e power x plus e power minus x by e power x plus e power minus x. Its range is between -1 and 1. These are some of the activation functions that is used in the neural network. Now let us see one example how the neural network can be applied. So for example, I want to predict the weather. Okay, so based on two conditions we can predict. One is the humidity and the temperature, how moist the air is, and how hot or cold it is. So I have this is the set data set. Humidity, temperature, and rain. If it is 1 means it is rain, and there is 0 means it is no rain. So if the humidity is 90% and temperature 25 degrees Celsius, there is a possibility of rain. If the humidity is 70 and temperature is 30 and there is no rain. If the humidity is 90% and the temperature is 20 degrees Celsius, there is a possibility of rain. If the humidity is 60 and the temperature is 35, then there is no possibility of rain. So this is my data set. So now I'm going to check for the some other conditions. So I'm giving here the input layer is only two cases. One is humidity and temperature. There are two input neurons. And hidden layer, we have to check high humidity increases means there is a chance of rain. Less humidity means there is no chance of rain. So the output layer, it will predict rain means 1 and no rain means it is 0. So like this we have to frame the input, output and the hidden layers. Now what are the steps? So the inputs are multiplied by the weights and passed to the hidden layer. So the hidden layer, it has an activation function. So based on the activation function, it will make the decision whether it is rain or no rain. And then finally you have the output layer. So activation layer gives the decisions and that will be given as a final prediction. So during the training, the network adjusts its weights to, if you want to get more of accuracy, then we have to adjust the weights. Next comes the types of neural network. We have for feed-forward neural networks, then multi-layer perceptron neural network, then recurrent neural network. Feed-forward, it is the simplest artificial neural network where the data is moves from the input to the output in only one direction. Multi-layer perceptron, it is a feed-forward network with they have more of layers. So including we have always you have input layer, hidden layer, output layer. That's it. If you have more number of hidden layer, then it comes under multi-layer perceptron. And a recurrent neural network, it is the network that is used for the sequential data processing. The sequential data processing is called as RNN, that is recurrent neural network. So it has the feedback loops, recurrent. So it uses the feedback loops, that means uses the past information, that is the memory it has. The first one is the forward propagation. So here the data input is passes through the network in the forward direction. So this is called as the forward propagation. So here you can see I have two input neurons and it has the weight as W1 and W2 and you have the output layer, that is Y. So Y is equal to input is multiplied with the weights and second input is multiplied with the weights, whatever you want, that is the output Y. So Y in equal to, this is the first neuron multiply with the weight, so x1 into W1, and second neuron multiply with the weights plus x2 into W2. So these together it gets added, you will get the output. So that is the output. So this is the here only a straight, you don't have the hidden, straight you have the output, but here input layer, hidden layer, and the output layer. So this input is multiplied with all two hidden layers, and this input is multiplied with this and this hidden layer. This input is multiplied with this and this hidden layer. So each one has its own weights. So if it multiply with this, you will get this hidden layer. This hidden layer is multiplied with this weight, you will get one output. And this hidden layer, it has a combinations of this one, and this one, all the weights. Okay. And this H2 is multiplied with W2K, it will get the output. So adding these two, you will get the final output. This is the processing of the artificial neural networks. Let us have an example and see how this neural network can be calculated. So here you have Z1, Z2, Z3, these are all the hidden layers. So now to find Z1, so Z1 is nothing but find the hidden layer of Z1. So I'm taking this as h of x for the first hidden layer. What are all connected here? This connection 1, from x1 is coming, from x2 it's coming. So from x0, these are all w1, these are all, second is w2, these are all w3. So I can take this as x0 into w1, x0, I'm taking this as w0, okay? x0 into w0, then x1 into w1, and then x2 into w2. All the weights are added. So you will get w1, x1 is 0, and x2 I'm taking the values of values as x0 is 1, x1 is 0, and x2 is 0. Okay. So now if you find this, you will get h of x is equal to 1. H of 1, I'm taking this h of 1 is equal to a. So now you have to find what is z. Z1, it's nothing but the activation function. So f of a, which is equal to a. So I'm taking the value as 1. Similarly, find for Z2. How will you find the values for Z2? Z2 it has x0 into W0, x1 into W1, x2 into W2. So you will get, when you multiply this, you will get again a, f of 1 equal to 1. Next find f of Z3. The same way you will get the output. Coming to f1 into Z0, now I'm going to find the value for D0. So D0 is nothing but you have some values here that is multiplied with its weight. So here Z1, what is Z1 here? Z1 is A, 1. Okay, so I'm taking this as Z0 into W0, Z1 into W1, Z2 into W2, Z3 into W3. These Z1, Z2, Z3, you know the values. 1, 1, 1, 1. Okay. And then W0, W0 is also 1. So if you're adding all these things, you will get 1 plus 1 plus 1 plus 1, you will get 4. Now find f of a equal to 4, which is equal to 4. So the output is equal to 4. So in this way only we have to calculate the values. So after calculating this, you have to find the loss. What is the loss? Actual minus predicted. Actual is 0, but the predicted is minus 4. So the actual value comes from the training set, and while the predictor value is our whatever, this is our model value, and actual value is the training set value, which is 0. So the interaction, the loss of this is minus 4. Okay. So if you want to reduce this loss, again we have to adjust the weights until you will get 0. So this process will continue until you will get the actual output is 0. So next comes a multi-layered neural network. So in multi-layered neural network, you have more of multiple layers will be there. Multiple hidden layers may be present. So here you have the nodes 1 represents the bias, and the leftmost layer, these are all the input layers, and these are all the hidden layers, and this is the output layers. So in this equation, you have 3 input layers, 1, 2, 3, 4 hidden layers, and 1 output layer, and you have the 1 bias. So this is the actual number of neurons, number of input layer, hidden layer, and output layer present in this network. So input layer, it resists the inputs, and hidden layer, it is the intermediate layer between the input and the output, and output layer, so it's used to find the predictions or the desired output. So this is the formula to find whatever we have seen previously, the same we have here. R is nothing but there you have used Z1, Z2, Z3, that is R. So you have to multiply with the weights. If you have any bias, then you have to add the bias or else leave it. And this h1 of n is nothing but whatever you're finding this, find the function of. So you can also use sigmoidal function or ReLU functions or Tranach functions to calculate the value. So this method is used in medical image processing. For all the image processing, medical image processing analysis, this is the best method, as well as for satellite images analysis also. This is the best method. So next comes the radial basis function. It is one of the type of the activation function, particularly used in this is used only in radial basis function neural net RBF neural networks. So it is different from the other activation functions like sigmoidal and ReLU, because there we have based on the inputs we will calculate, but here it uses the Euclidean distance. It is used only the distance between the input and the center point. So based on that, it will find the distance and it will calculate. So this is widely used for pattern recognition and for classifications. This can be used. For this network, RBF activation function is used. So it is a special category of the feed-forward neural network. It is fully depends on used on the distance from the center point. So here also you have the 3 layers. One is the input layer, then hidden layers, and the output layer. Let us see one example for calculating the RBF network. So here in RBF, input vectors are there, and RBF neurons are present, and then activation function. So this is based on the Euclidean distance, and then output node. So when we do one problem, we'll understand how this RBF network will work. So this is the architecture of the RBF neuron. Here you have the input. The RBF neuron, here you are using the RBF activation function, and you have the output. So this activation function is based on the Euclidean distance. So these are some of the concepts of RBF. So first, the center of the RBF. So each RBF neuron, it has a center, which is the prototype point, which is the center point in the input space. You have to find the distance from the input and the center. You have to find. And then radial activation. For that distance between these two things, you have to find the activation. So the common RBF function used is Gaussian function is used. So this is the formula, e power minus of x minus c. So x minus c is the distance between the input and the center point, and the sigma is the parameter controller for the width of the radial function. So this is the structure of the neural network. And the RBF network is worked for the two cases, one for the training phase and for the prediction phase. So when you see the advantages, it works with the small data sets, and we have to carefully select the center, then only it will give the more accurate results. So if you have if you have more of hidden layers than the feed forward networks, it may require this network require more what is that feed forward hidden layers are needed, as we are using in the feed forward network. Let us take one example for the RBF neural network. So here I have to going to apply the RBF neural network for predicting the whether the temperature of the room is comfortable or uncomfortable. So here we have two data. One is for temperature and humidity. Based on the temperature and the humidity, we are making the comfort level as if the temperature is 20 and humidity 40, it is comfortable. If it is 25 and 50, it is also comfortable. If it is more than 25, that is 30 and 60, it is uncomfortable, and 35 and 70, it is uncomfortable. This is my data sets. Now I'm going to test for these are all given. These are all training sets. Okay. So now I'm going to test for some condition, whether that condition comes under comfortable or uncomfortable. How to check using RBF, how the training or how the network works for such data. So first, next one is we have to use a Gaussian. This is the formula, e power minus gamma d square. D square is the equivalent distance, and the gamma is the control. Okay, now we have to find the equivalent distance as you see in the previous formula, xi minus the center point. So now, for the same given data set, I'm going to check for this condition. If the temperature is 27 and humidity is 55, what is the comfort level? That is what we are going to check now. So now for that, you have to find the equivalent distance between the input and the center points. So first I'm taking the data points 1 and 2. This is the data points 1 and 2. I'm taking 20 temperature and 40. That is the first data set. And second one is 25 and 50. I'm taking these two data sets, finding the distance, and similarly find the distance for the remaining as well. So how will you find the distance for 20 and 40? What is the actual temperature for? We are going to test for 27 and 50. So 27 minus this 20, the whole square, plus humidity 55 minus 40, the whole square. Okay, so you will get one value. Similarly, find for the second. So 27 minus 25, the whole square, and 55 minus 50, the whole square. Find the y distance. Similarly, find the distance for 30. That is 27 minus 30, the whole square, and 55 minus 60. Similarly, for 35 and 70, you will get the distance. Like this, you will get the distance. So after finding the distance, now you find the RBF function, activation function. So gamma is nothing but the learning rate. Okay. So 0.01 I am taking. So phi d equal e power minus 0.01 into d square. First find for 16.55 the first case, second case, and you have 4 functions, so 4 zones. So 4 values you have to find. So I'm getting the values 0.64, 0.74, all these things. Okay, for the remaining 2 cases. This for comfortable. and this is for the uncomfortable. Now, after finding this, so this is what we have obtained. Okay, now we have to find this output. How will you find this output? This W1 into this first hidden layer, then W2 into the second hidden layer. Like that, you have 4 layers. So W3 into, this is for the for comfort alone you have to take. So comfort you have two categories, W1 and W2. Therefore, W1 into the first comfort activation, W2 into the second comfort activation. So you have to take these weights, or randomly you can choose the weights and apply the weights and get the output. So I'm getting the comfort for the weight as 0.5434. That is the output you're getting for the comfort zone. And for the uncomfortable, find the weights W3 into, so I'm taking the weights as 0.6 and 0.4, and you find the uncomfortable output as 0.446. Now we have to check whether the given so now I'm having the comfortable output as 0.54 and uncomfortable is 0.44. So here 0.54 is greater value when compared to this. Since this 0.54 is greater, I can predict that the model classifies the input as comfortable, because whichever is greater, that value gives the output. If the uncomfortable has a higher value, then we can classify that as uncomfortable. Therefore, for this 27 and this 30, we'll get the zone as comfortable. Similarly, we can find for the next temperature 40 and 75. That same procedure, find the equivalent distance. After finding the equivalent distance, find the activation function and then compare the outputs. Whichever is greater, that will be predicted. So this is the way we have to this algorithm will perform. So now we have another example is classifying the fruits based on the size and the weights. So I have different sizes and different weights. If it is this size and this weight, means it is apple. If it is this size and this weight, means if it is an orange. Like that we have to classify. Now I'm going to check with the new size as 7.5 centimeter and 170. So it comes under whether it is an apple or an orange. That we need to check. So first find the equivalent distance for all the four, and then apply the RBL functions. After applying that, you have to check with the apple and orange separately and see which has the highest value. So here I am getting apple as 0.19 and this is 0.22. Therefore, because here 0.19 is the higher value, therefore orange has the higher value, the fruit classified under orange. So next comes the adaptive learning rate. So it is a technique used in neural network where the learning rate is adjusted automatically during the training period. Okay, so adapt in the sense automatically learning. Automatically it was learning in the neural network. So this, since it is automatically learning, so it will gives a faster output, faster accuracy, and also gives it is more of efficient. So here we have the learning rate. So determines how much the weights are adjusted during the training period. If you have a small learning rate, the training is also very slow. If you have the larger learning rate, then the training will be very high and the accuracy will be more. So adaptive learning rate idea. So instead of using a fixed learning point, not one, if we have adaptive learning rate, then the learning rate based on the process of training, it will give us more accurate outputs. So for example, larger output updates when the error is high and smaller updates when the error is low. So if you are having the adaptive learning rate, the benefits you have the faster convergence. That means very quickly it will produce the output. It avoids oscillations and it gives the better performance for the models with, even if it is a complex data, it will give the better performance. Next one is the weight update rule. So the weight update rule in Redis basis functions. Okay, so once you get some values, if you want to update the weight, So how to update the weights? So we have to use a gradient descent rule to update the weights. So this is the formula to update the weight using this gradient descent. That is, new weight is equal to Wi bold plus eta is the learning rate and y is the actual output and minus y is the predicted, what we are predicting, and multiplied with the activation function of the RBF. So in this way we can find the new weights. So if you are adjusting the weights, so every time it produces some new weights. So if it automatically adjusts the weights, means very quickly it will converge. That means very quickly it reaches the output. For example, if you have my target is 0.5, I'm getting 0.7. So it will update the weights and may reduces to 0.6, and the next reduces. Like that, number of iterations will take place. Epochs we call. So it takes place, and to reduces the in order to reduces the last function, or else to converge. It undergoes various epochs. So let's have an example how to update the weights in RBF neural network. So I'm having the input as this one 7.5 and 170. Actual output I want only one for orange. Predicted output I got zero 0.8. The learning rate is 0.1. The activation function for 5.1 and 5.2 is this, and initial weights are given. So now using this formula, you have to check for the new weights. So W1 plus eta y minus y bar into 5.1. Okay. So you know the value for W1, you know, eta values, you know, and actual output and the predicted output into 5.1 is the activation functions. So find the weights. So the previous weight is 0.5. Now we got the new weight as 0.507. Okay, even each decimal values matters a lot. And similarly for W2, we got 0.4, but here we have 0.4, not 24. Okay, that is the weight we got as a new updation. And again it will compare and you will get some output. Still it is not predicting properly. Again the weights is adjusted. So this will be keep on adjusting the weights until you get the actual output. So next comes the recurrent neural network. So recurrent neural, in this network, the information flows in one direction from the input to the output, usually in the neural network. But the recurrent neural networks, it will feed back to the system for every step, because you have the input, hidden layer, then output. So in that hidden layer, it again is fed back. So that we call it as a recurrent neural network. So it allows the network to remember the past information by feeding the output from one step to the another step. So for example, when we are predicting the next word in the sentence, the RNN network using the previous words, whatever the previous word it has. So based on that, it gives the prediction. Okay, so that is called as the recurrent. So I will tell you an example. So it remembers the past input using a hidden state, which helps in understand the sequences. For example, I'm giving the input sentence as I am going to the, that's all. So what the recurrent will check is, first it will check first I, that is the input. So based on the previous memory, what it will predict the word as am. Then based on the word I am, it will predict the word as going. So based on the I'm going, it predicts as to. Based on to, going to, it predicts the. Based on going to the, predicts the market. Okay. I want to write if I'm writing a story, once upon a time, there was a, so the recurrent neural network, it is based on story. So there was maybe a king, or it may be a queen. In some places like that, it will keep on predict the words based on the information what it has in the previous. Whereas other neural network, it doesn't have, whatever the input you are giving, it will give the output. That's all. So based on the informations, whatever it has stored, it will not predict predict the output. So that is best advantage in this recurrent neural network. So this is the feed forward neural network. Whatever the inputs we have, it will just forward, and whatever the hidden layer we have, let's multiply with the weights and it will gives the output. That's it. But the recurrent neural network, see here, this is the input layer, this is the recurrent neuron. So whatever the inputs it has, so it will again recollect the previous past informations. All the information will be stored here, and then for the next predictions, it use this information, the memory informations, and then it will gives the output. So that we call it as recurrent neural network. So the FIFO network struggled with the sequential data. Sequential data, it will get struggled since because it has a lack of memory. It doesn't have a memory. It will has it struggle to give the what is the next prediction. Whereas this recurrent neuron, it can easily gives the information because it has a ability to understand or to recollect the memories which is stored, informations which is stored in the memory. So this is the recurrent network. Here you have the input and this is the output, and this is what is the information stored in the memory. So here if I want h of t, it should know the previous informations. If I want h of t plus 1, the previous information is h of t. So these, if I want h of t plus 1, all these informations will be stored in the memory. Based on these two informations, this will perform and it will predict the next data. So this is given very clearly in this image. So this is x of t, wx is its weight for this, and you have the hidden layer. This hidden layer has its weights, and h of t minus 1 is the previous informations, and y of t is the output hidden layer, and y is the output. Now to find h of t, I want h of t. So it's a function of x of t is multiplied with this weights plus this h of t minus 1 is the past information. It is multiplied with the weights. Plus if you have bias, you can add or else leave it. And then, so this is h of t. How will you find y of t? This h of t is multiplied with this w of y. So that is y of t. That y of t only you will get as an output. So when you're finding this h of t, it will multiply with the weights and whatever I am going to. So it will multiply the inputs I am going to, and the previous informations are stored. I am going to the, everything will be stored in the memory. So using those words, it will predict the output as, so based on which category. I'm going for a shop, I'm going to a market, I'm going to buy a vegetable. So I am going to the, next it will not give it as it may be a, based on the words which is using. It is used to predict market or mall or going to shopping. Next, real-time recurrent learning. It is an algorithm that is used to, it will train the recurrent neural network in real time. So by updating the weights at each step. Okay, so by adjusting the weights at each step in real time. So that is called a real-time recurrent learning. So let us have an example, sentiment analysis using recurrent neural network. So sentiment analysis is nothing but it's a process of determining whether the sentence, whatever we are talking, the sentence, it gives a positive or the negative opinion. Okay. So based on that, it will predict accordingly. So now, for example, I'm taking, this is this movie was terrible. I regret watching it. This is one sentence. So this sentence will be we have to train RNN and classify this sentence as whether it is a positive review or negative review that we have to give. This RNN has to predict and give whether the given sentence is a positive review or negative review. How it does? So now we have to form certain data set, prepare a data set based on the reviews. For example, this movie is fantastic. I love it. It's a very positive review. So giving the analysis as one positive. This movie was dull and boring. That is not the positive comment, so it is negative. Absolutely loved the acting, positive. The songs are very, very good. Then I hate this movie. It's the worst ever. So that is negative. So these are the data sets we have. Like that, we can have many number of reviews. So now the neural network RNN can be trained by using these reviews. So how it will learn? So using these reviews, it will take the good words and bad words. The good words as fantastic, amazing, brilliant, superb, like that. All the words it will take it as positive or good words, and negative words as boring, dull, bad, terrible. So like that, it will take all the bad words like this. So it will classify as these words comes under positive sentiment and these words comes under negative sentiment. It will classify as two. Now, now we are giving one comment review. The movie was terrible. I regret watching it. So what? Suddenly, by using this information, the recurrent will compare with all the good words and bad words. So here it shows some terrible. So terrible comes under bad words. So it immediately it will gives predict and gives the comment as negative. Predator sentiment is negative. So in this way, only the recurrent neural network will train, learn, and train the network. So now you imagine a smart voice assistant like Alexa or Siri. So how this RTL, real-time recurrent neural network works. So when I say play my favorite song, so now what will happen? The Google Assistant or the smart voice assistants, it will go by sentence, word by word, and it will try to understand the intent. It's mentioned as play and also you have song. Then it updates its learning immediately using RTL. Okay. Then if a person says play some rock music, so it will learn like rock music and it will update in real time. If I say stop the music, it will learn it as stop. Okay, and adjust. So when I say play my favorite song, so immediately it will understand the word play song. So some song it will play. If you given us some favorite song, one song is my favorite, means it will store all the data favorite songs as one list, one one cluster, and whenever I say my favorite songs, so it will just play that song. Okay. So in this way only this our real-time recurrent neural network will work. So this can be used in applications where we have the stock market predictions, very, very important market predictions for analyzing the data continuously. And self-driving the cars, and self-driving cars, it should go properly by getting the data from the sensor. If the data is getting from the sensor, it's proper. If it is correct, then it will move accordingly. So for that, and also we have the Google Map, because Google Map is every time it is giving us to giving the directions to follow. So all comes under this real-time recurrent neural network. The next one is the back propagation in neural network. So back propagation it involves in training a neural network. Forward propagation, it is input, weights multiplied, hidden layer to output layer. But here this back propagation, it will adjust the weights. Suppose if you are getting the output as some error, some loss function, automatically what you have to do, you have to adjust the weights. The back propagation, just the back. From the back, it will adjust the weights, fine tuning the weights. So that's why it's called as backpropagation neural network. It will not go from the forward, it will adjust the weights from the backward direction. So that means output is the input layer, and the hidden layer is the output layer for the first case, and then you have the hidden layer is the input, and the input layer is your output. Like that it will go in a back propagate way. So this is the actual feed forward layers. Input, you have the hidden layer. You can have multiple hidden layers, and you have the output. But back propagation, what it will adjust the weights from here. This is the input to this case, to the hidden layer, and this hidden layer to this hidden layer. And from this hidden layer, this is the input case, and this is the output case from the backward direction. So how it will work, how the back propagation works. So we have to, for this, the step one is we have to calculate the gradients. So gradients are nothing but, because you are adjusting the weights here, right? So Wij is the new weights, which is equal to eta, which is eta is always the learning rate. And del J is the error term for each unit has some error into Oj. Oj is nothing but the neurons. So let's see one problem where we how to adjust the weights. Already we have seen this problem in feed forward network. So I have given only input and the inputs and the hidden layers, and these are the values we got from the forward propagation. Okay, now I'm assuming this as this is y3. Okay, output y3. So I'm taking this as delta 3. And this is y4, I'm taking this as delta 4, and this is y5, I'm taking this as delta 5. So now you have to find two things. One is find the output error as well as the hidden error you have to find. Okay, so how to find the output error? Output error, this is O3. Here you have the term called delta 5. So take it as delta 5 is equal to, this is the formula. Delta 5 belongs to y5, so it is y5, and 1 is the 1, formula is 1 minus this y5 into y target minus y5. What is my target? I am giving the target as 0.5. 0.5 is my target. So I am taking this y target as 0.5 and y5 is 0.67. Okay, so that is what we have to give here. So y5 is 0.67, 1 minus 0.65, and y target is 0.5 minus 0.65, you will get minus 0.17. To multiply all together, you will get minus 0.0376. So that is delta 5. Please make a note. Now coming to the error in the hidden unit. So now coming to the H1. The H1, I am taking this as delta 3. This is delta 3. So delta 3, how will you find? Y3 into 1 minus y3 and the weights. Okay, here this is the hidden layer is based on weights, right? So you have to multiply the weights into, this is the input into weights, right? This belongs to delta 5, so it is delta 5. So clear? So to find delta 3, this is the input and this is the weights. So y3 into 1 minus y3 and multiply the weights and this delta value. So W13 and delta 5. So you will get one value. How will you find H2? H2 belongs to Y4 and delta 4. So I am taking this as delta 4. This is Y4. This is the input and this is the weights. So you have to take 1 minus Y4 and here the weight is W23. It's multiplied with delta 5. So multiply with this, you will get H2. Okay. So now how will you find H1? So to find H1, so you have to find all these weights. Okay, now you have to find W23. This weight you have to find. So 1 into, go as the same procedure, 1 into the previous input, multiply 1 minus that into previous input into that weights. So you will get this value W23. Okay, now we have to update the weights. So now I want to find the W23. So W23 is 1 into, this is delta phi and this is eta phi. So find this delta and the output and the input. So I will get these values. So this is my new weight. So W11 is equal to 1 into, you have to take the del 3 and your output Y1. So this is the value. So these are the new weights we got for this. Similarly, find W12, 13, 21 and 22. So these are the new weights. And compared to the previous weights, this you can add. This weights you are getting. And apply the same propagation techniques to get the output. Still, if you have the error, again the back propagation will applied. Again, it will adjust the weights, and you will get the new weights. To get the again new weights, again it will compare, and you will get. So this process will continue until you will get the actual output. So now we got the output as Y3 as 0.5, 0.56, 0.67. So when you find the actual output 0.5 minus 0.61, this is Y5, Y61, you are getting minus 0.11, which is not equal to 0. So again the next iteration will take place. Update the weights and check the output. Then in that cases it may be minus 0.2, minus 0.1. Again it will update the weights until you will get the output as 0. So if the output is 0 means it is actually predicted your testing. So Nickeron network back propagation through time. So back propagation through time BPTT. It is used to update the network parameters. So here the loss function L of 0 is nothing but the output. Output is nothing but your comparing with the actual and the predicted output. That is the loss function we have. So how this LT? So this will depends on H3. This hidden layer that depends on H2. H2 depends on H1. H1 depends on H0. Okay, in a sequential order. Since it is a back propagation, it will come in the reverse way. So next one is the self-organizing map. So it is nothing but an unsupervised neural network that is used for clustering and dimensionality reduction. So supervised learning means it undergoes various learning, okay, training, and learning is undergoes learning. But unsupervised doesn't have any learning. On the spot, it will learns, and based on that learning, it will make a used for clustering and dimensionality reduction. So in competitive learning, the input is compared to all neurons. The neuron whose weights are nearer to the input is the best matching. So the winner and the neighboring neurons update the weights to resemble the input. So this process continues and gradually forming the clusters of same. So for example, I have apple, orange, pineapple all together. So now when I when I test one apple, so what it will just compare with the segregated groups. So what are all apple shape? Maybe shape with the shape we can segregate, or we can form a cluster, or we can using the color we can cluster. Okay, if it is red, if you are using a shape means it will have the apple shape. It will compare the shape of the apple, orange and pineapple. So it compares with the orange, doesn't match. Then it compares with the pineapple, doesn't match. If it compares with the apple, it match. It will segregate. Like that, it will segregate all the. If you have thousands of fruits there, it will segregate all and put it in one group and name it as apple. That is one cluster. Then like that it will segregate all the different apples, and so whenever if you are giving for testing an apple means it compare with all the clusters, and if that matches then it will gives the output as apple. So in this way only this will work, but here it will not undergoes any training, or it is not supervised, it's unsupervised, so it doesn't have any training. So through this learning only it will, through learning it will predict. Next, by multidimensional networks. These are all the advanced neural network used for process and analyze the data with multiple have the multiple dimensions. So nowadays we have the social network analysis. For social network, we have multiple users are there, not only one or two. We have thousands or lakhs of users will be there. So for processing and analyze the data, we have to go for this multi-dimensional network. So each user we can name it as one node and the connections between them. So I'm the user. I'm have various connections I have, right? So all these connections I will take it this will form a multiple layer. So in that I have friends, I have so many followers, I have colleagues, I have the home details I have. Like that, each category will be making as one layer. So this forms multiple layer for one user. Similarly, you have to think for the n number of users has n number of multiple layers, and this we call it as multi-dimensional network. So for multi-dimensional network is represented by G equal to VEL. V is the self set of nodes and E is the set of edges, nothing but the how many connections, and L is the set of layers. So how many layers we need for each connection. If I have 10 connections for one user, I have 10 layers. So we have seen the introduction to neural network and what are the different algorithms that is used for a neural network, like for feed forward network, then recurrent neural network, then RBF neural network we have seen, then back propagation neural network, and we have seen some self-organizing map. So these will help us to understand how a neural network. This is an introduction part of neural network. So in this module, I have seen only the introduction and how the neural network and other different architectures will perform based on their network. So I hope you all have understood the concepts that I have explained in each neural network. I hope we will meet you soon in the next module. Thank you all.